Stories of a CISP.
Hey, welcome to my first episode of Stories of a CISP. The incredibly salacious voice you heard at the beginning of this video was none other than my lovely wife. So I thank her very much for participating in my CISSP stuff. This is a series where I do my best to talk about my real-life job as a network security engineer and explain how I always wind up applying, finding, or relating some sort of CISP topic to whatever I do. I'm a network security engineer as a professional job. This CISSP website and CISP instructor thing is just kind of my hobby. And it was this correlation between my day job and my night job that played a huge part of my own CISP exam. There was definitely something from my real-life experience that helped me answer a question correctly on the real exam. Somehow the books, practice questions, and concepts we learn always relate back to real life. And it is this correlation that will pull through for you at the end when you do sit down to take your exam. As it should, right? The 8 domains of the CISP exam are supposed to compose the entirety of information security. We should be able to apply it to our real-world jobs, even if it is in the slightest way. This episode deals with the TCP Handshake, which is part of Domain 4, Network Security in our study guides. Just a quick review, and this is of course in relation to the CISP exam as well. The TCP Handshake is what is required to establish a full TCP connection. TCP, or Transmission Control Protocol, is what we use for when we need a connection confirmation between a client and a server. When you connect to a web server, you are using TCP. When you SSH into a Linux box, you are using TCP. When you send email, you are using TCP. All these types of connections require confirmation and requires TCP and the TCP handshake to do so. Here are the components of a TCP handshake. A client initiates a TCP connection to a web server. The client sends a SYN flag. SYN stands for synchronization. The server receives a SYN segment and sends back two things: the server's own SYN flag, along with an acknowledgement of the client's initial SYN flag, otherwise known as an ACK flag. In the first step, the client sent a SYN flag, okay? And in the second step, the server sends back a SYN ACK. I know you've probably heard all this already in all those hundreds of TCP handshake videos on YouTube. I know you're diligently studying for your exam, and I just want to say, don't give up, okay? You will make it, I promise. Okay, and the client receives the server's SYN ACK and proceeds to send back its own acknowledgement of the server's SYN flag, which is called the ACK. Okay, that's the TCP handshake. SYN, SYN ACK, ACK. If you work in a technical networking field right now, you're probably rolling your eyes because of the simplicity of it all, that you probably see this kind of stuff in packet captures all day, just like me. So after the TCP handshake, after all this is done, that's when the data starts to pass back and forth between client and server. That's when, if you go to a website, the TCP handshake occurs first in at the speed of light, basically, at a microsecond. Well, not exactly the speed of light, because we can never reach the speed of light. We can only come close to it. Actually, it is the speed of light, isn't it? All those fiber optics going through our systems? Yeah, my bad. It is the speed of light. What is it, 286,000 miles per second? Yeah, something like that. So we need that TCP handshake to occur right away. And once that happens, that's when you start seeing the web page. If you go to google.com, your computer will do a TCP handshake, and then the website will load. I know it just takes like a fraction of a second, but all that goes on before that web page, before you see that web page in front of you. It's awesome, really. Now that we got that squared away, this is my story. When there are network connectivity issues at the Security Operations Center where I work, the first thing to be blamed is the firewall. 40% of my job is just proving that the issue is not with the firewall. The simplest of tasks is just showing the customer that traffic has ingressed and egressed successfully out of a dual or multi-homed security device. At the Managed Security Service Provider, MSSP, we manage the firewalls of customer A. We do not manage the switches, we do not manage the routers or the load balancers or the servers for customer A. We just deal with firewall issues. Over the weekend, on a Sunday a few years back, customer A added a new server to their network environment. Okay? On Sunday, connectivity was working fine at this point. But on Monday morning, when I walk in, connectivity was broken, right? First thing Monday morning, come in, see a ticket. Hey, Luke, this doesn't work. I'm like, okay. Priority 1 phone calls start rolling into the SOC. I get the call of a frustrated project manager who is demanding to check the firewall as to why traffic is suddenly dropping to the server. I asked them, this is what I do for every troubleshooting call. I asked them for a source and destination IP address in order to begin capturing packets and figuring out where things are going wrong.
Press 1 to enter the conference.
This particular customer's firewall was a Cisco ASA version 8.6, I believe. It was post version 8.3 when all those ASA NAT changes happened. Not important for this video to know, but just something I know some, Cisco engineers out there might enjoy hearing. Basically, it's me telling other network engineers that I know what I'm talking about. Because when I hear a network security engineer talk about ASAs and network address translation, if they know the major change that happened with the ASAs post 8.3 versions, then I know for sure they know what they're talking about. They're the real deal. I don't know many CISP instructors that know that either, that kind of technical knowledge, except me, and most likely Larry Greenblatt as well. He's a technical guy, who is also a great CISP instructor, by the way. Check him out if you can. He's professional, he's friendly, and down to earth. Though if you have seen his content, you will know, even though he's down to earth, you will know that his mind is beyond this galaxy. Okay, so me, in another way, if you want to look at it in a cryptographic sense, me talking about ASA changes, 8.3, 8.4, if I say that to someone else who knows the same thing, it's kind of like our secret key. We can confirm to each other that, hey, we both know that 8.3 NAT changes occurred, and that means we both really kind of know how ASAs work. That's our secret key that we share, that we confirmed our knowledge to each other. Anyway, the connectivity to a newly added server was working fine on Sunday, but stopped working while I happened to be at work on Monday morning. When it's things like this, I immediately ask for a troubleshooting conference so we can do some packet captures on the phone in real time and see what's happening with the traffic. Because after all, packets do not lie. This is the command to do a packet capture on the Cisco ASA. It goes something like capture, the name of the packet capture, which would be INT. The interface is inside interface, meaning facing the servers. And we're matching IP 10 to 179/32. All this command is saying is do a packet capture on the inside interface of the firewall for IP address 10.2.1.179. Whether it is ingressing or egressing out the network, whether it is the source or the destination. I entered this command on the firewall and asked the customer to generate some traffic between his machine to the newly added server. Then I entered this command to show the results of my packet capture on the command line. Show cap int, meaning show, capture, and the name of my capture, which was int, as you can see from back here. And this is what it showed. Okay, lot of stuff going on here. Remember in your CISP studies how you're studying in Domain 4 Network Security about the TCP three-way handshake, right? You've done that, I'm sure, as I know you're studying very hard. Well, the above output is a real-life example of this. We use this simple output to determine if a connection has been established or not, or just if traffic is traversing the firewall at all. Traffic could be going through the firewall, but being dropped somewhere else. For your information security career, this is the real reason you are studying the TCP handshake, to know that it can be used quickly and efficiently to troubleshoot connections. Here's a breakdown of what is going on. In line 1, a SYN packet is being sent from the source to the destination. In line 2, a SYN ACK is being sent back from the destination to the source. In line 3, an ACK is being sent from the original source back to the destination. In lines 4 and 5, you start to see data flowing back and forth via the P flag. P stands for push. Because firewalls are a layer 3 device, and because TCP is a layer 4 protocol, we were safely able to tell the customer that this is not a networking issue on the firewall, since we as network security engineers were responsible for just those 2 layers. Remember, I said we at the SOC are only responsible for the firewall, and this device deals with layer 3 and 4. Mostly layer 3. Officially layer 3. Firewalls are a layer 3 device. And everything in those 2 layers, as from our point of view, were operating as they should. Just real quick, why aren't we responsible for any OSI Model layer 2 issues? Because that deals with switches. We don't deal with switches. Why aren't we responsible for layers 5, 6, and 7? Those layers are more associated with the application, so the user's workstation or the server itself. We don't have access to those. That's not part of our duties. And why weren't we responsible for layer 1? Because all this infrastructure, all these devices, they're all located miles away from our SOC, and we didn't have hands-on access to the fiber optic cables, or the NIC cards, or the power cables, or whatever other physical stuff. We had to call other people for that. Okay? So since we didn't deal with any of the other layers and confirm the packets were going back and forth as they should in layers 3 and 4, we were safely able to tell the customer that this is not a networking issue on the firewall. They would need to either check the networking devices in between the source and destination, or they would need to check OSI Model's layers 5, 6, 7, and maybe even 2. But it wouldn't be 2, would it? Because packets have already made it through layer 1, layer 2, layer 3, and layer 4. So we can confidently eliminate layers 1, 2, 3, 4, and it's got to be something on 5, 6, and 7. Well, we came to find out that the configuration on the load balancers, which resides right before the servers and after the firewalls, was changed on Monday morning by another party without a proper change management process or any kind of approval or any notifications sent out to other parties. That was the cause of their connectivity issues. Just another day as a CISP at a security professional job. Nothing crazy, right? This is just security stuff that I deal with all day with a very focused set of concepts that also applies to the CISP exam. You can read all the books you want about TCP Handshake, about the OSI model layers. You can read that Cybex and Sean Harris book and Domain 4 and OSI model a 1,000 times. But if you don't see how it's done in the real world, you'll never truly understand it. You never will. You just won't. You'll just know it academically, and that doesn't translate in the real world. And you're taking this exam for the real world. You know, you're not just taking this exam just to pass an exam and then go into your job and be like, yeah, I'm a CISP, and then they hand you a TCP Handshake packet, and you're like, well, what is this? They're like, I thought you said you're a CISP. You're supposed to know all this. Okay. For Domain 3, security engineering, well, let's now go over the CISP concepts as it relates to my particular experience in this scenario. Like, what CISP concepts can we relate to what I just talked about? For Domain 3, security engineering, we have the concept of separation of duties. Did you catch that? When in this video did we mention a form of separation of duties? When did we mention that? Or how was that kind of seen here? That would be the fact that the SOC engineers are responsible for the firewall, the NOC engineers are responsible for the switches, routers, load balancers, the server team is responsible for the servers, and the data center team is responsible for the physical connectivity. Not one person is responsible for everything from client to server. Okay, separation of duties. For Domain 4, network security, that's pretty much this whole video, right? We talked about the transmission control protocol, otherwise known as TCP. We talked about the three-way handshake, the cornerstone of all TCP connections. Without it, you have no TCP connection. We even talked about and showed IP networking when we did our packet captures. Your basic network troubleshooting using the TCP three-way handshake. We also dealt with private IP addresses and not public IP addresses when we were entering private IP addresses in our packet captures, that 10.IP. That 10.IP is not public, it's private, right? RFC 1918, you all knew that, right? I'm sure you did. These packets don't go out to the internet. Well, then how were they connecting, you may ask? Were they using network address translation? If you said that, that's a great guess, but not in this scenario, because we used an MPLS. It's just private IPs going through a private MPLS connection. The traffic wasn't going over the internet. That's how. And we also touched upon Domain 7, security operations, and the concept of proper change management. The load balancer team did not follow proper change protocol. Otherwise, all parties would have been involved, as well as interdependencies. And you know, the load balancer team, I don't think they even had a change management process, or even if they did, the guys working on it, they didn't really follow it. It wasn't really enforced. But since that mistake where it caused an outage for a customer or the connectivity issues for a customer, they started following that change management protocol from then on. And we received notifications every Sunday after that. Okay, hey, thanks for watching my first episode of Stories of a CISP. I'll keep making more as the experiences come in, of which there is no shortage in security profession. Again, I said the CISP stuff is my hobby. If you want to sign up for my CISP course platform, it currently has 56 hours of videos, over 850 practice questions with full explanations, over 1,500 flashcards, tons of downloadable PDF notes, and access to a private CISP Telegram group, and you can email me anytime. Yeah, all of the content has been hand created by me over the 7 years I've been a CISP instructor. And just to show some credibility for me, I'm not just a random dude on the internet. I have written a book called How to Think Like a Manager for the CISP exam, which is now one of the top 5 books recommended by the ISC Squared for your preparation towards the CISP exam, and something that this thing has pretty much done nothing less than blown my mind. I would have never thought a book I've written that's only 60 pages at that would be one of the top 5 books for the CISP exam. Honestly, I never thought that. Just also want to say that, hey, keep studying, fellow security professionals. I know you can do it. There are 2 factors that are working positively for you, which is on your side right now. Statistically, there has never been a better time to pass your CISP exam, given the abundance of resources available. I mean, just look to the right of your screen. All those preview videos I'm showing up right now of CISP videos, maybe even TCP Handshake videos. It's all at your disposal. Don't let that knowledge go to waste. And the other thing is, there has never been a higher need for security professionals today than ever before. You can pretty much name your own salary these days, the date being May 2022. Okay? You have more resources now than ever to pass the CISP exam, and there's a high demand for information security professionals. Don't let this opportunity and this time right now go to waste. Take advantage of that. I swear it'll set you up for the next 20 years of your life. Okay? Thanks for watching. See you in the next episode.